Hello everyone. So today the topic of discussion is Mosfet behavior in presence of inductive load. So as you can see this circuit where there is a n-channel Mosfet switching on the inductive load. So for example, the inductive load can be motor or relays or transformer or any speakers. So these are some of the inductive load you can consider, and this is a n-channel MOSFET which is switching on this inductive load, and I have used a gate driver circuit to drive the gate of the MOSFET. So let's try to understand what are the problems when you use the inductive load and how to solve that problems. So when the MOSFET is turned on, so the MOSFET gets turned on when you supply the positive pulse at the gate. So it turns on, and then the equivalent circuit can be drawn as, so it is plus, minus, and then you have an inductor, and then this behave as a short circuit. So this is your when MOSFET is on, and when the MOSFET is off, it means you give a negative pulse or the low pulse, and then the MOSFET is turned off and your equivalent circuit becomes, this is your inductor, and then here is a open circuit. So what happen when the MOSFET is on, so since this is a inductor and the current start flowing through it, then it will try to charge and it will store energy in forms of magnetic field. But when the you turn off the MOSFET, what will happen? So when the MOSFET is turned off, so whatever the stored energy are there, so as you know the property of inductor that it does not allow sudden change in current, or as per the Lenz's law, it says that it opposes the cause which has produced it. So whatever the magnetic fields are there, it will suddenly do not collapse, okay, and because of that it will form a EMF across it, and the sign will be opposite of this, okay. So here it will be minus and here it will be plus, so it will develop a EMF across it, and since it will develop a EMF across it, and then there is not any path to discharge, so it will develop a high value of voltage across it. So that is why you call it as a spikes like this. You can also see through a waveform. So let's suppose this is VDS or VGS, okay, and when I am providing a positive pulse, okay, when I am providing a positive pulse, so my VDS it becomes zero because it is a short circuit. So for this, okay, it will become zero. But the moment I provide a low pulse or negative pulse, so it will behave like it will have a spikes, okay, and it will be ringing, and then again it will settle down. Again, there is a high pulse, so it will VDS will be zero. Then again there will be spikes. So you see this spikes, this is because of this inductor, okay. Now how to prevent this, okay, so you can prevent it by connecting a parallel diode. So you connect a diode across it, okay, you connect a diode across it. So this diode is you also called as a flyback diode or fly wheeling diodes or reverse bias diodes. So what happens when the voltage is developed across this inductor, so during turn off situations, it will have this path. Okay, it will have this path to discharge its energy through this path. Okay, so we will not see this spikes. So